Okay, this is our second ray tracing. This time, instead of having a convex mirror, I have a concave mirror. And concave mirrors can also be called converging mirrors because they can form real objects, real images. So let's shade this in. And again, I do this to show that this is the side of the diagram where light never actually passes. And I'm going to draw the image. In this case, I'm going to have it beyond the radius. And if I do that, I'm going to put it out here, right at the left-hand side of this. Let's make it 3 units high in the vertical. The vertical scale does not have to be the same as the horizontal scale. And I screwed that up already. Let's write an object. There we go. So, let's look at the 3 beams that we have, the 3 rays. One is going to be the undeflected ray. Undeflected. And that has to do with the radius of curvature here. If I drew a line between the radius of curvature and this circle, and if I draw on the circle to scale, you would see this, that ray is going to be perpendicular to that surface, which means it's right on the normal, which means it reflects back on itself. So I'm going to draw a ray coming from the tip of that arrow and going through the radius. And I'm going to draw it all the way to this red vertical line which goes off the page. So here's number 1. It goes in like this. It comes back like that. So here, this is 1 there. Undeflected through the near radius of curvature. That's number 1. The other 2 rays that I've had in the last example were rays that shared 2 properties. One is that one of the beams was parallel to the axis, like this. And the other property they shared is a focal point. So let's just draw the parallel ingoing beam and see what develops. I'm going to draw it all the way to the vertical line again. 2 parallel ingoing. Ingoing, incoming, same thing. And if I look at where the normal is right here, it's going to be pointing downward. And that means that this is going to reflect towards the axis and probably cross the axis at some point. And so that means that drawing from the vertical line, it's going to go like this. So that's 2. Parallel ingoing is going to be outgoing through the near focal point. And number 3 is going to be the other way around. It's going to be parallel outgoing, but going through a focal point on the way in. That should be this guy right here. So 3 is incoming through the near focal point, and it's going to be parallel outgoing. Let's do that. So from the tip of the arrow through F, and it really pays to have a straight edge like this and to be using graph paper. You get the very accurate outcome. And so this is number 3. And here's the punchline. All 3 of these rays, after they bounce off the mirror, go through this point right here. That means we have an image right there. Let me draw the arrow. It's going to point downward through this point, and I'll label it IMG. Now let's look at the 3 properties of an image. This one, is it real or virtual? Well, the rays cross right there, so that's real. Is it upright or inverted? That's right, it's inverted. Is it enlarged or reduced? Well, we look at the length of this versus the length of that in the vertical, and it's reduced. So that's how we do a concave mirror.